So about 10 years ago now, I started working on Open Joystick, which is like a project to make a parametric design for a 3D printable joystick for flight simulators. It's pretty much dead, that project. I sort of lost interest in it when I bought myself a fancy joystick. I feel bad for abandoning it, but yeah, it's been surpassed these days. People have done way more, far better than I ever did. So I'm happy that that field hasn't died. But there's another thing that I've been fiddling with. So I made this a few years ago, which is a box covered in knobs for trim wheels for a flight simulator. And the idea is that you bind each of the knobs to a different function of the plane. Like I think this one was elevator trim, that was rudder trim, what have you. It works really well. And I also built a AHCP, an armament HUD control panel from an A10C. The switches map through inside the simulator. That was pretty great. And I've seen people make these kinds of things for Kerbal Space Program primarily, and they're pretty cool. So they're bespoke controllers that are made for a specific space simulator. There's another example. It's got some buttons and some sliders and some cool toggly switches with like lids over the top. So you open up the lid, open up the gate, I think it's called, and flick the switch, and it's got joysticks on it. And it's made specifically for that particular game. There's a few examples of these. And there's heaps of different things like this where somebody wants to replicate either a specific panel from a specific aircraft, or they want to make a general purpose controller for a specific simulator. So I'm thinking it might be possible to do something in the middle by making a modular control board. So the fundamentals would be one box that handles the USB interface to the computer, and that would have a 32U4, I think, is the best option, microcontroller in it. And it might just have a one button on it or what have you. But then it'll have some contacts on the side for, 5 volts, data, and ground. G and D, come on, pull it together. And then you'd have a range of boxes. So you'd have a box that has maybe just one massive mushroom button on it that's red, and you slam it, and that's like your abort. And so it'll have some sort of locking mechanism, some sort of location mechanism that will click that onto that. And then if you make a range of different types of these modules, and they can be quite cheap, like one might just have like a rotary knob on it. And it'll have buttons, contacts on the side, and the locking mechanism, probably magnets, something like that. Some sort of hook arrangement on the top, and then a latch arrangement on the bottom. That's quite easily 3D printable, something like that. So the top end latches into a mating hole on this side, and then this little shelf for that hook to latch into, something like that. We've got a range of options, but we just need to have 3 maybe pogo pins or sprung pins or something like that. You can get little surface mount tabs that kind of look like that. So they've got a bit of compressibility here, so you can get good contact with 2 of them touching together as these 2 surfaces mate. So that might be an option. Or pogo pins, or we've got some other ideas. So other options for boxes. So my AHCP had a bunch of switches, so maybe just one that's like six little single throw, single pole switches. So I think it was one of these ones here. These modules you see here, these little joysticks, they have X, Y, and twist, and a button on the top. And these are a separate module. So if you make this device, make this sort of front surface here big enough to fit one of those on, you just bong one of those on the top, and then you can lock them and add them, and then you can assemble together a grid of these in whatever arrangement you want, and assemble your own control panel of boxes to suit, whatever simulator you want to run. And I think that'd be really neat. It's a good way of getting sort of a middle ground. So the challenging thing is that the 32U4, which handles the USB HID emulation, I think it's the one I used in OpenJoystick. I think that's a 32U4 there. It needs a few extra components and resistors. I think it needs an external crystal and all that. So the total bill of materials for those is about $8, which is not heaps, but it's more than you'd want in one of these things. Like the box is going to be maybe 40 cents worth of 3D printed plastic and let's say 20 minutes of machine time to make. And then you're probably going to have a custom PCB on the interface sides. And once you're paying for 4 of those interface boards and the board inside, you start to getting up around the just $20 worth of electronics just for one box, which is not cheap. So I'd like to get the cost down if possible. Maxim used to make an awesome little board that just had 4 analog inputs, analog to digital converter inputs, and then 1 wire. So with this approach, you could have your switches or your potentiometers, your knob signals, just going into the ADCs, and then you have your 1 wire coming out over your data pin. However, they don't make these anymore, which makes me sad. But there might be some other option. And these things were cheap as chips, like less than $1. But other like commercial joysticks have like a shift register where they have, like, let's say 4 digital inputs and then a clock signal and then 1 data out. So these are in. And when you clock this 4 times, you get the state clocked out serially over this line here. They work great for digital inputs, but for analog inputs, it's not so great. There are a couple of I2C or SPI options for sampling the pins, but there's sort of no good dense middle ground that I've found yet. If you know of one, please tell me. To detect, let's say, up to 6 digital inputs and 1 digital and XYZ, 3 analog. The 32U4, coming back to that, has got like 8 analog inputs, I think, and they're reasonably high accuracy. They're like 11-bit or 12-bit, which should be more than good enough. But again, quite pricey. But, there's something to be said for having sort of a homogeneous hardware. It might be possible to make the PCB, like if I find sort of sprung edge connectors that could go out like that. That might be an option to make the bill of materials a bit simpler and faster to assemble. Because if the little interface boards on the side, where did I draw it? Where are we? Oh god, I lost it. If the little interface boards with the springy doodles on them have to have another ribbon cable that connects them back to the main the microcontroller, then that's 4 extra little sub-assemblies that you need and 4 different wires, and this becomes a slower to assemble, more things to go wrong. So I don't know, another option might be some sockets, and then you have a ribbon that you plug into the socket. It comes out and goes into the adjacent one, goes into the adjacent module. So you plug from one socket to another, like a surface mount ribbon. It only used to have 3 wires, so I don't know, maybe a dip socket or something like that. I'm planning to have these PCBs made by JLC, who I've used in the past. So if it's in JLC's catalog, that'd be a big plus. But yeah, anyway, that's my idea. So basically, a way of assembling one of these things out of modular components that you can reconfigure for any simulator you want to run, or even if you want some extra inputs. So you could build this one out of, like, a flippy toggle switch, so that could be one type with some of these. We could probably fit 4 of these round buttons on there. There's an example of the big panic button, the big panic mushroom button. Yeah, there you go. There's one with that sort of lid over the top. That's what I'm thinking of. You have to sort of twist them to unlock them. Don't know about this keyboard though. Kexis Instruments. That's pretty good. That's a good one. Okay, that's my idea. Bye bye.